Section 1. The unsung hero in your engine bay. A lead-acid battery is one of those things we rarely think about until it fails us, usually on the coldest morning of the year or in a deserted parking lot late at night. It's the silent, heavy box of potential energy tucked away under the hood of your car inside your boat or powering your off-grid cabin. At its core, it's a beautifully simple, yet powerful, chemical device. It doesn't create energy, it stores it, acting like a rechargeable reservoir of electrical power ready to unleash a massive jolt to crank an engine to life or provide a steady stream of electricity for lights and accessories. This process relies on a chemical reaction between lead plates and a sulfuric acid solution, called an electrolyte. It's a robust and reliable technology that has been with us for over a century. Its ability to store and deliver power diminishes over time. This is where testing comes in, and it's a game changer. Instead of waiting for that inevitable inconvenient moment of failure, you can proactively check on your battery's health. Testing empowers you to move, from guessing to knowing. Is your car slow to start because the battery is dying, or is there another issue? Is the battery just low on charge, or has it suffered a catastrophic internal failure? Answering these questions can save you a ton of time, a significant amount of money, and the massive headache of being stranded. This essay is your guide to becoming a battery whisperer, teaching you 3 essential straightforward tests to diagnose its condition accurately. The beauty of these tests is their simplicity. You don't need a degree in electrical engineering or a $1,000 diagnostic machine. With a few affordable tools and a bit of know-how, you can get a clear picture of what's happening inside that black box. We're going to break down the hydrometer test, which gives you a cell-by-cell health report. Then we'll cover the open circuit voltage test, a quick and easy way to gauge the battery's overall state of charge. Section 2. Safety first, donning the armor before the battle. Before a single tool touches the battery, our first priority is protecting ourselves. Lead-acid batteries demand respect. The electrolyte is sulfuric acid, highly corrosive. It can cause severe chemical burns to your skin and permanent damage to your eyes. This is not the time to be cavalier. The very first items you should put on are a pair of wraparound safety glasses goggles, not the cool sunglasses you wear driving, but proper, impact-rated eye protection that shields you from splashes from any angle. Your eyesight is irreplaceable. This single, simple step is the most important one you will take. Nitrile gloves, neoprene gloves. If, despite your precautions, you do get some acid on your skin, you need to act immediately. Don't panic, just flush the affected area with copious amounts of cool, running water for at least 15 minutes. It's also a great idea to have a box of baking soda mixed with water nearby. This alkaline solution can be used to neutralize any acid spills on your garage floor or tools, but for skin contact, plain water is the first and best response. Always work in an area with good airflow, as charging batteries can release hydrogen gas. Hydrogen is odorless, colorless, and highly explosive. Another crucial safety rule is to eliminate any potential ignition sources from your workspace. No smoking, no sparks, no open flames anywhere near the battery. This is also why you should always remove any metal jewelry before you begin. If a metal ring were to accidentally bridge the gap between the positive terminal and a grounded part of the car, it could heat up instantly, causing a severe burn and creating a dangerous arc. Make sure the battery is on a stable, flat surface where it won't tip over. Keep your tools neatly arranged and away from the top of the battery itself to prevent accidental short circuits. Always connect and disconnect chargers and testers in the correct sequence. A good rule of thumb is to connect the positive, the red clamp, first, then the negative, the black clamp. When disconnecting, reverse the order. Remove the negative, the black clamp, first, then the positive, the red. This minimizes the chance of creating a spark near the battery vents. By building these safety habits, you turn a potentially hazardous job into a safe and routine diagnostic procedure. Section 3. Your arsenal. Gathering the right tools for the job. With our safety protocols firmly in place, let's assemble the specific tools we'll need to properly interrogate our lead-acid battery. Having the right gear not only makes the job easier and more accurate, but also safer. The first and most versatile tool in our kit is the digital multimeter, often abbreviated as DMM. For our purposes, we just need one with a basic DC voltage setting. Section 4. The hydrometer test. A deep dive into the battery's soul. The hydrometer test is arguably the most definitive test you can perform on a serviceable lead-acid battery. While voltage tests give you a great overview, the hydrometer allows you to peer inside and assess the health of each individual cell. A standard 12-volt car battery is actually made up of 6 separate 2.1-volt cells connected in series. The hydrometer test helps you determine if all 6 cells are pulling their weight equally. A significant discrepancy between cells is a telltale sign that the battery is on its way out, even if the overall voltage seems acceptable at first glance. This test is only possible on batteries with removable caps, often called serviceable or maintenance-type batteries. If your battery is a sealed, maintenance-free type, you will have to skip this step. Let's walk through the process. With your safety glasses and gloves on, carefully pry or unscrew the caps. Then squeeze the bulb and insert the pickup tube into the first cell. Be sure the tube is submerged in the fluid. Now, slowly release the bulb. Draw in enough fluid so the float lifts freely, without touching the top or bottom. Hold the hydrometer perfectly vertical at eye level to avoid a parallax error. A fully charged healthy cell reads around 1.265 to 1.280. 1.225 is about 50%, and 1.100 is discharged. Section 5. The Open Circuit Voltage Test. Taking the battery's pulse. The Open Circuit Voltage, or OCV, test is the quickest way to snapshot state of charge. The battery must be at rest with no loads or charger. Let it sit for a few hours, preferably overnight, to remove surface charge. Set your multimeter to DC volts. A 20-volt range is perfect. Touch red to positive, black to negative, and press into the lead for solid contact. The multimeter will immediately display the voltage. Now interpret that number. 12.6 or higher is near 100%. 12.4 is roughly 75. 12.2 about 50. 12.0 near 25. Below 11.9 indicates fully discharged or a serious problem. Sitting below 12.2 volts can lead to sulfation, permanently reducing capacity. If OCV is low, charge fully, let it rest, and recheck. If it now holds 12.6 or more, the battery might be fine. The issue may be your charging system or a parasitic drain. If a fully charged battery's OCV quickly falls back down, it likely can't hold a charge and is ready for replacement. This is the test that separates the rookies from the pros. The voltage drop test is a brilliant diagnostic technique, finding problems in connections and cables. You can have the world's strongest battery, but if power can't reach the starter efficiently, you'll still struggle to start. This test measures resistance as voltage lost under load. You'll need a digital multimeter and a helper to crank the engine. We'll test the positive side first. Set the meter to 2V or 20V DC. Place red on the positive post, not the clamp. Place black on the starter's main post. With the engine off, you should read almost 0 volts. Now crank for 5 to 10 seconds and watch the meter as the starter draws hundreds of amps. A healthy positive circuit drops less than 0.5 volts. 1 volt or more points to excessive resistance. Common causes include corroded terminals, a loose clamp, or internal corrosion you can't see. Now repeat for the ground side. Place red on a clean engine block surface, black on the battery's negative post. Now that we have performed our 3 distinct tests, it's time to put on our detective hats and piece together the clues. Each test gives us a different part of the story. By combining them, we can arrive at a confident and accurate diagnosis. It's rare that one single test tells you everything. The real power is in correlation. Scenario 1, OCV is a healthy 12.7 volts, but positive side voltage drop hits 1.5 volts while cranking. The battery is likely excellent. The pathway is the issue. Meticulously inspect, clean, and tighten every connection from battery to starter. Look for swelling or damage in the cable. Fixing this likely solves starting. Scenario 2, 5 cells at 1.260, 1 cell at 1.120. After charging, OCV tops at 12.3 and quickly drops. Classic internal failure, shorted or sulfated cell. Replace the battery. Scenario 3, OCV 12.1, all cells uniformly low. After a full charge and rest, OCV holds at 12.65 with healthy specific gravity. Battery is fine. Find the cause of discharge. Often, the difference between a battery that works and one that doesn't comes down to simple maintenance. Corrosion looks harmless, but it's an electrical insulator. Mix baking soda and water, scrub with a toothbrush or terminal brush and let it neutralize. Rinse with a small amount of clean water and dry thoroughly. Push clamps fully down onto the posts and tighten securely. You shouldn't be able to twist them by hand. Apply a thin layer of dielectric grease or a spray-on terminal protector to slow corrosion. In serviceable batteries, low electrolyte can expose plates and cause damage. Use only distilled water. Fill to the bottom of the fill ring. Do not overfill. Check cables for fraying, brittleness, bulges, or internal corrosion that raises resistance. If compromised, replace the entire cable assembly. Cleaning won't fix internal rot. These simple inspections and fixes can restore performance and save you the cost of a new battery. After inspections, cleaning, charging, and testing, you arrive at a decision. The data will guide you to one of three conclusions: repair, charge, or replace. Choose repair when internal health looks good but voltage drop under cranking is high. Clean and tighten connections and grounds. Choose charge when hydrometer readings are uniformly low and OCV is low, but it accepts and holds a full charge, 12.6 plus volts and 1.265 plus SG. Replace when SG varies significantly between cells, or when OCV plummets below 12.4 after resting. Clear internal failure. Most lead-acid car batteries last 3 to 5 years. Age plus symptoms favors replacement. In conclusion, a systematic approach: safety first, then hydrometer, open circuit voltage, and voltage drop lets you stop guessing and start knowing. Clean a corroded terminal, charge a low battery, or replace a failed one with confidence. Regular cleaning and proper charging extend battery life and ensure it's ready when you need it most.